Welcome once again to our online lecture of B.Sc. first year Analytical Chemistry. Dear students, in last lecture we have learned about the purity of the precipitate and the co-precipitation. So what is the co-precipitation? That are the impurities which are get occluded or which are get introduced into the main precipitate during the formation of precipitate is during the formation of precipitate is known as the co-precipitate, and the process is known as the co-precipitation. So we want to get the pure precipitate, then we want to minimize two types of the precipitation, that is co-precipitation and the post-precipitation. So co-precipitation is the precipitate, that is impurities which is occluded or included during the formation of precipitate is known as a co-precipitate, or the process is known as a co-precipitation, and the occlusion or the inclusion or the incorporation of the impurities into the precipitate after formation of precipitate is known as a post-precipitation. So how this co-precipitation is get minimized during the formation of precipitate, and what is meant by the post-precipitation we will see in detail in today's lecture. So let's see the elimination methods of elimination of the precipitate, that is nothing but co-precipitate. So let's see what is the methods of minimization and elimination of co-precipitate. So co-precipitated impurities can be eliminated generally in the 5 ways. So what are the 5 ways which is used for the elimination of the co-precipitate or co-precipitated impurities? A first method is by digestion of precipitate. Digestion means what? The heating of the solution at the elevated temperature to increase the size. What is the aim of digestion? To increase the particle size, but the second aim of this digestion or aging of the precipitate is to dissolve the unwanted impurity, that is what the foreign substances may get incorporated into the solution, that is what the precipitate. So co-precipitated impurities can be released during the true Ostwald repainting. For example, what is true Ostwald repainting? It is nothing but digestion. For example, we could get a very pure calcium oxalate by precipitating it first in very fine particles and then allowing them to ripen, that is digest, for some time. Similarly, that is 94% of the co-precipitated lead nitrate can be removed from the lead sulfate, that is lead sulfate, after 6-hour digestion with 0.01 normal, that is nitric acid at 95 degrees Celsius. So there are two examples given about the repainting or the digestion by which we can remove the impurities, that is co-precipitated impurities. So by using the Ostwald repainting or digestion aging, we can remove the impurities which are get mixed with the oxalate precipitate. So we can get the calcium oxalate precipitate by precipitating it first in very fine particles and then allowing them to ripen and digest for some time. Similarly, 94% of precipitated lead nitrate can be removed from lead sulfate after 6-hour digestion with 0.01 normal HNO3 at 95 degree Celsius. So this is what by means of the aging or digestion of the precipitate. The second method to eliminate the co-precipitated impurities is by washing of precipitate. Some of the co-precipitated impurities can be eliminated by washing the precipitate with an suitable electrolyte solution. Gelatinous precipitate like FeOH thrice and AlOH thrice must be washed with a electrolyte solution uh, to eliminate the uh, precipitate, that is co-precipitated impurities. So by means of the washing we can also remove the impurities, that is precipitated impurities. So this washing of the solution to prevent the peptidation and to help in the displacing absorbed impurities for the hydrous oxide of aluminum, and that is what FeOH thrice and AlOH thrice. Ammonium nitrate is the best wash solution. So these impurities which are getting occluded or incorporated in the solution, that is the precipitate of iron that is ferric trihydroxide and aluminum trihydroxide is eliminated by means of the washing with the ammonium nitrate which is the what best washing solution. Then a third type of the method used for the removing precipitate, co-precipitate, that is co-precipitated impurities, and by precipitation, reprecipitation, by allowing or the performing the precipitation one or more time, or by reprecipitation we can remove the impurity. So an obvious way to remove the some of the co-precipitated impurities from precipitate is to dissolve the precipitate in an acid or an alkali if possible, and then precipitate where by part of the impurity which the PPT contain originally is left behind in the solution, and when the precipitate is formed for second time. For example, this is the method for the what the reprecipitation means. What we dissolve the precipitate into the alkali or acid solution, the if that get reprecipitated, whereby the part of the impurity which the PPT contain originally is left behind in the solution when the precipitate is formed for second time. For example, the hydrous ferric oxide can be dissolved in dilute HCl and then precipitated by adding ammonia. So calcium oxalate and magnesium oxalate can be treated in the same way. So what happens? The hydrous ferric oxide can be dissolved in the dilute HCl and then precipitated by the adding ammonia. So calcium oxalate and magnesium oxalate can be treated in the same way for the what removing the co-precipitate. Then fourth method, by the control of pH or by addition of two reagents. So the co-precipitated impurity can be minimized by the addition of two reagents instead of one reagent. So we use two reagents instead of one reagent. Only a precipitant, so an additional reagent can be added to the control the pH to maintain the pH at which impurity does not precipitate. So we maintain the pH and will get the original precipitate, and the impurities get not precipitated, so they go into the solution. Then fifth type of the method is by separation of the impurity. The co-precipitated impurity can be minimized by mechanical separation of impurity from the solution before the precipitation of main ion by the suitable method. So this is the mechanical method. We can separate the precipitate by means of the filtering or by means of the any physical means. So we can minimize the precipitate or the co-precipitated impurities by means of the using 5 ways. The first way is to digest the precipitate. The second way is by washing the precipitate. Then third way is by reprecipitation. fourth is by the control of pH or by addition of two reagent, and fifth way is by the separation of impurities by means of the mechanical means. So the co-precipitated impurity can be minimized by the mechanical separation of impurity from the solution before the precipitation of the main ion by suitable method. So this is about the post precipitation, how this co-precipitation, how this co-precipitate is get eliminated or minimized by means of the various different 5 methods. The next type of the precipitation is the post precipitation. So what is the post precipitation? The process by which the soluble impurities enter into the or get incorporated into the main precipitate after the formation of main precipitate is called as the post precipitation. So what is the post precipitation? The process by which the soluble impurities get entered or get incorporated into the main precipitate after formation of the main precipitate is called as the post precipitation. So before and after, during and the after precipitation. During the precipitation, the impurities which get included or incorporated into the main precipitate, then this type of the precipitation process is known as the co-precipitation. And if the soluble impurities enter into the or the get incorporated into the main precipitate after formation of main precipitate, then this type of the precipitation is called as the post precipitation. In this process, the impurity enter into the main precipitate gradually by deposition on the surface of main precipitate after the complete formation of main precipitate. So this type of the impurities get deposited on the surface of main precipitate after the completion of or formation of the main precipitate. This occurs when the precipitate and impurities are in contact with each other for longer time. So when this happens, when the precipitate and the impurities are in contact with each other for a longer time. So more is the duration of the contact of impurity with the main precipitate, more is the most precipitation. Hence the amount of impurity increases with time, with increasing time. So if you want to minimize the post precipitation, then do not keep the precipitate, that is precipitated impurities, in contact with the main precipitate. So for example of this post precipitation is, if the calcium oxalate, that is CaC2O4 precipitate, is formed in the presence of impurity, that is Mg+2 ion, then after complete formation of main calcium oxalate precipitate, the impurity, that is magnesium Mg+2 ion, also get post precipitated as a magnesium oxalate, that is MgC2O4. So it occurs by adsorption of the common ion on the surface of main precipitate. After the complete formation of main calcium oxalate precipitate, the excess of C2O4 ion is get absorbed on the common ion and the surface of the CaC2O4 precipitate. Then the absorbed layer of Ca, that is C2O4, and on the CaC2O4 precipitate attract the impurities of the Mg+2 ion from the solution, and a layer of the MgC2O4 impurities get formed on the surface of the main calcium oxalate precipitate. This way the post precipitation of impurity, that is magnesium oxalate, occurs after the formation of main calcium oxalate precipitate. So what happened, how this calcium oxalate is formed, and after that formation of the calcium oxalate, due to the common ion effect, the oxalate ion get absorbed on the surface of the calcium oxalate precipitate. Then this calcium oxalate ion attracts the impurity that is which are in contact with the precipitate, that is Mg plus 2, and that it is the formation of the magnesium oxalate precipitate is taken place, and that is incorporation of the magnesium oxalate, that is magnesium impurity, into the precipitate takes place. Then next one is the minimization of that or elimination of that what the post precipitation precipitate. So method of minimization: the post precipitation process is unwanted process from the analytical point of view, so it should be minimized if not completely eliminated. Following are the two methods by which we can minimize the post precipitation or minimize the post precipitation. So first method is the by immediate filtration of the precipitate. So the post precipitation can be minimized by the filtration of precipitate immediately after its formation without allowing it to remain in contact with the impurity ions in the solution. So this is the very important step for the what the minimizing or eliminating the that is post precipitation. What we will have to do is that the after the formation of the complete precipitate, immediately filter the precipitate and avoid the precipitate in contact with the impurities. So by immediate filtration of the precipitate, we can remove the impurities or the minimize the impurity, that is post precipitation impurities. So the post precipitation can be minimized by the filtration of the precipitate immediately after its formation without allowing it to remain in contact with the impurity ions in the solution. So for example, the calcium oxalate precipitate in contact with the Mg plus 2 ion impurity should be immediately filtered. So after that, that magnesium plus 2 will not come in contact with the calcium oxalate. So it is what the it restrict the formation of the magnesium oxalate precipitate. So second method for the elimination of the precipitate is the by separation of the impurities. So the post precipitated impurities can be minimized by the mechanical separation of the impurity from the solution before the precipitation of main ion by suitable methods. So first, that is what the remove the post precipitation impurities before the formation of the main precipitation. By means of the mechanical way, we can eliminate the or we can minimize the post precipitation. So the example of that is separation of impurities, that is Mg plus 2 ion, from the solution before precipitation of Ca plus plus ion in an calcium oxalate precipitate. So firstly, remove the that impurities before the filtration or the before the precipitation of the ions, that is calcium ions. Firstly, what the remove the Mg plus 2 ion from the solution before the precipitation of calcium ion by means of the mechanical way or the by means of filtration. So in this way, in this lecture we have discussed about the minimization of the co-precipitation. What are the 5 methods of the minimization of the co-precipitation, then what is post precipitation, and how this post precipitation is minimized. So what are the methods for the minimization of co-precipitation? There are 5 methods of the minimization of co-precipitation. First method is by the digestion of precipitate. We can remove the impurities, and by washing of the precipitate we can remove the impurities. By reprecipitation we can remove the co-precipitated impurities. By control of the pH or by addition of the 2 reagent we can remove the co-precipitation precipitated impurities. And fifth method is the by separation of the impurities. We can, by mechanical way, we can separate the impurities, and we can minimize the co-precipitation. Next is what the post precipitation. What is the post precipitation? Precipitation is nothing but the process by which the soluble impurities enter into the or incorporated into the main precipitate after formation of main precipitate, and this process is known as the co-precipitation. Example of that is what the in the calcium, during the formation, after the formation of calcium oxalate, the magnesium oxalate impurity, that is post precipitation, is occur on the surface of calcium oxalate. Then what are the methods of minimization? There are two methods of the minimization of the post precipitate. That is, one is the by immediate filtration of the precipitate, and second one is the by separation of the impurities. So we can minimize or we can eliminate the precipitate. That is what post precipitation. So this is about the methods of minimization or elimination of the co-precipitate, and what post precipitation, and the methods of minimization of post precipitated impurities. If you have any queries related to this topic, please put your question in YouTube comment box. I will try to answer. In next lecture, we are going to learn about the precipitation from homogeneous solution and the apparatus used for the filtration. So thank you, thanks a lot. We will see in next lecture. Thank you.